Good day, everyone. I've come once again to teach you today. Today, I want us to discuss one of the most difficult topics that students find in mathematics. The topic is no other one but longitude and latitude. I remember most times if I ask my students the particular topic that they are finding difficult, they used to mention three. Number one is longitude and latitude. Number two is bearing and distance, and number three is construction. All right, today we want to discuss one of the most difficult topics we have in mathematics according to students, but when you follow me, I will show you that it is not difficult at all. You know, in every difficult thing we have secrets. Okay, well, once you know the secret of that thing, it will not be difficult anymore. So follow me. Let me show you the secret of solving longitude and latitude in mathematics so that it will not be difficult to you anymore. Let's go. All right. Longitude and latitude, or latitude and longitude. Let's start with longitude. All right. I have longitude like this. Longitude. All right. When you hear longitude, what does it mean? This longitude. You see, when you are talking about latitude and longitude, you are considering what? Earth. The earth, you know, looks like this. You have earth like this. Okay. We have earth like this. Yeah, this earth. Nigeria is part of it. Africa is part of it. Asia is part of it. Ghana, Zimbabwe, Zambia. All of us, we are inside here. All right, so when you have earth like this, and we are talking about longitude. All right, this longitude is the what? Imaginary line that can be drawn from. Remember, when you have something like this, we have this place to be north. Is it clear? And we have this place to be what? South. Remember, here we have it to be what? East, and we have it to be what? West, like this. The four cardinal points. All right. So the vertical imaginary lines that can run from north to south, that is what we refer to as what? Longitude. So longitude may be something like this. Can you see it? Like this. This. It has to come from north to south. Okay. It can also be in this form. Can you see it? This kind of line, vertical line from north to south, or you may say from south to north, whichever one. This line is what we refer to as what? Longitude. Can you see it? We have it as what? Longitude. Can you see the longitude here? Longitude. Right? So anytime you are talking about longitude, know that you are referring to what? You are referring to imaginary vertical line that can run from north to south on the earth cross like this. Can you see that? So this will refer to it as what? Longitude. All right, this longitude, we use it to locate position of points on this earth surface. So how do we go about that? We have a reference point. A reference point, maybe something like this. One particular reference point is also a vertical line like this. Can you see it? A vertical line like this. This one, we call it prime meridian. Prime meridian, that's the reference point. Why do we call it reference point? I will explain. We have prime meridian like this, prime meridian like this. So this reference point is from this. You have to be comparing the points that you are talking about, east distance from this prime meridian. Just like if you want to direct somebody, maybe you want to give direction of somewhere to somebody. First of all, you have to find out what that person know, the area the person know, or location the person know already. So from that location, you now be telling him, maybe follow right or follow left. For example, if the person knows maybe a particular church or a particular mosque or a particular school very close to that place that you want to direct him, you ask him, do you know, let's say, Central School? So central school. The person will say yes. Is it clear? Automatically that central school will now become what? Reference point. You will now say, when you get to that central school, follow left, follow right, right of what? That central school. Left of what? That central school. At the back of central school. In front of central school. Adjacent of central school. Now, the person has known a particular place. You are now directing the person with respect to what he or she has known already. So that central school is what? The reference point. Is it clear? So because based on that central school, you'll be giving your own what? Direction. Is it clear? So if there is no reference point, you cannot locate any point on earth. So you have to have a reference point. So the direction that you are giving now should be the distance away from that reference point, or angle that the direction that the point that you are trying to locate will make with that reference point. Can you see? And this reference point here, we call it what? Prime meridian. Remember, all these longitude, they are called what? Meridians. So either you say latitude, or you call either you say longitude, or you call it what? Meridian. So this longitude can also be called what? Meridian. Can you see? All of them, they are called meridian. But why we call this one prime meridian is that is the reference point. Is it clear? That means this meridian is what? A kind of special, because from here every other one should be what? Located. Is it clear? All right. So you notice that when you look at this now, you notice that this meridian, which is a longitude, it can go towards what? The east. Like, can you see this one? It can go towards the east. Then can you see this one? It can also go towards what? The west. Is it clear? So how do we measure this, or how do we draw this? Although in mathematics we don't do measurement, we just draw it freehand sketch. All right. So but the actual way of doing it is that from this prime meridian going towards the east, you have from 0 to what? You have from 0 to 180 degrees east. Can you see? So at this point, this prime meridian, the angle is supposed to be 0. Can you see? The angle is supposed to be 0. Any longitude that passes through this prime meridian, that one should be regarded as what? Being 0. Is it clear? That is 0 distance from where? 0 distance from the prime meridian, or 0 degree from where? The prime meridian. In fact, anyone that passes through this prime meridian is regarded as what? Being 0. Is it clear? Now, if you are moving away from here, going towards the east, from here you have 1, 2, 3, 4, 5. As you are moving like this, it will keep on increasing until it gets to what? 180 degrees. So this does not mean 0 minus 180. It means 0 to 180 degrees. Can you see? So from prime meridian going towards the east, the angle will keep on increasing. 0, 1, 2, 3, 4, 5, 6 until you get to what? Maximum, which is 180 degrees east. Likewise, from that prime meridian, if you are going towards the left hand side, it will be increasing from 0 to 1, 2, 3. So you are also going to have something like this. So like this, you are going to have this. So if you are coming towards this side, here should be what? 0, 1, 2, 3, 4 until you get to maximum, which is what? Which is let me write this very well. Which is 180. We have like this, west. Can you see? From 0 to 180 degrees this. Can you see it? So if I'm coming from here now, going towards this, I'll have 1, 2, 3, 4, 5, 6, 7, 8 until I go to what? I get to 180 degrees west. If I'm coming from here, I'll have 0, 1, 2, 3 until I get to what? 180 degrees east. All right. So remember, I said that every longitude can also be called what? Meridian. Is it clear? Whether it's going towards the east or it's going towards what? The west. It can be called what? Meridian. But this prime one, this main one that is acting as what? A reference, that is what we call what? Prime meridian. And every other longitude should be reference to that. Is it clear? That is the yardstick that every other thing should be used. All right, so that is longitude for you. Then let's talk about latitude. When you have latitude, all right, when it comes to latitude, we are talking about horizontal imaginary line. Remember here we considered vertical imaginary line, but when it comes to latitude, we consider what? Horizontal imaginary line. Can you see the imaginary lines like this? Can you see that? Imaginary lines like this on this surface of Earth. Is it clear? All right. Then when you have something like this, you notice that these horizontal imaginary lines, they will form, when you cut this in now, the top surface will form a circle. Is it clear? Just that this is a diagram. If not, if you bring the group and cut it just like this now, the surface will form a circle when you look at it. All right. So this is what we call what? Latitude. Why this one is called what? Longitude. All right. Just like we have here prime meridian, we also have what we call equator. All right. So what is the difference between this equator and this other latitudes? Even the equator itself is also what? It's also a latitude, but it's a special kind of what? Latitude. Why is it special? All right. When you look at this now, you notice that this circle that this one will form, its radius will be smaller. It will be smaller like we're looking at this now. The radius of this will be smaller. Look at this one will be the biggest. Can you see it? The one that will pass through the center of this circle. This line, when you cut this circle, the line that will pass through the center of this Earth. When you cut this Earth into two through this line, this will be what? The largest diameter. Is it clear? It will be the largest diameter. So this particular one, we call it what? Equator. It's a kind of latitude, but the maximum latitude. Is it clear? The maximum latitude. It has the maximum diameter. That's what it is called, what? Equator. All right. Why every other one we call them what? Latitude. So we have latitude, 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 even up here, latitude, latitude. When you look at this latitude now, you notice that some come towards what? The south. Why some? They come towards what? The north. Is it clear? All right. So at this equator, this latitude, everything here should be 0. Just like at this prime meridian, everything here is what? 0. So from this equator here now, if you are going down like this, you notice that the angle will be increasing. You'll be having 1, 2, 3, 4 until you get to the maximum. The maximum is what? Is 90. All right. So for equator, we have 0 to what? 90 degrees. So if you are coming from here to this place, you are going to what? So it should be south like this. Can you see it? Can you see it? So all these ones, look at it here. Here should be 0, 1, 2, 3, 4, 5, 6, 7 until you get to what? 90 degrees. Can you see? Likewise, if you are going up here is 0. Here should be 1, 2, 3, 4. You are moving up until you get to maximum, which is also what? 90. That means from here, you'll be going towards this. You are going to have 0 to what? 0 to 90 degrees what? North. Can you see? So from here, 0 to 90 degrees north. From here, 0 to 90 degrees what? South. So that is how this thing can be done. All right, we have example 1. Example 1 says, find the difference in longitude between point X and point Y. So we have solution like this. If you are asked to solve something like this, you ask yourself, what are the longitudes that we are talking about? Look at the longitude of point X. It is what? 16 degrees east. Then for point Y, the longitude is what? 47 degrees west. If they are on the same side, for example, east-east or west-west, you do subtraction. You subtract the smaller one from the bigger one. But if they are on different directions, like east and west or west and north, you do what? Addition. Like here now, we have east and west. They are on different sides, so it should be addition. So you say this one will give us what? You have 16 degrees plus what? You have 47 degrees. Can you see that? So 7 plus 6 will give us 13. So you write 3, carry 1. You say this one, 4 plus 1 will give us 5 plus 1, you have 6. You have this 63 degrees. Can you see? So the difference here is what? 63 degrees. That is for A. For B, we have like this. You ask yourself again, what is the longitude we have here? We have 18 degrees west. The longitude we have here is what? 93 degree west. All right. So we have west and west. They are on the same side. Remember what I said? When you have the same side, you do subtraction. Subtract the smaller one from the bigger one. So this one will give us the bigger one, which is 93 degrees. Then you say minus, this one is what? 18 degrees. Why are we doing subtraction? Because they are on the same side. All right, so you're going to have something like this. When you subtract this, 8 minus 3 cannot go. Borrow 1 from here, call it 10, add it to this 13. 13 minus 8 will give us what? It will give us 5. Can you see that? Then this one, we have 8 left. 8 minus 1 will give us 7. So you have like this. We have it to be 75 degrees. So that is how it can be solved. All right, we have example 2. Example 2 says, calculate the difference in latitude in the following positions on the Earth's surface. We have solution like this. Number A, we have A 84 degrees north. You have 32 degrees west like this. For B, we have this. We have 61 degrees south and we have 32 degrees west like this. Can you see that? They say difference in what? Latitude. You ask yourself the latitude. The latitude we have here is north and south. Is it not? Yes. So here, the latitude we have here is 84 degrees north. And the latitude we have here is what? Is 61 degrees south. All right. So you notice that when you have in opposite direction, you have addition like north and south. When it comes to latitude, you add. But when you have south-south, you subtract. When you have north-north, you subtract. So here we have north and south. So we are doing addition. What do we have here? We have 84 degrees plus we have 61 degrees like this. When you add this thing together, 4 plus 1 will give us 5. And 8 plus 6 will give us 14. So we have like this. This will give us what? 145 degrees. All right, for B part of it, we have this. We have our C. We have 46 degrees south. We have this degrees east. Can you see that? We have this one to be this 79 degrees south. Then we have 70 degrees east like this. All right, when you look at this now, the latitude we have south and north. So when you look at this now, the latitude of this is on southern part of it. This one also south. So they are on the same direction. Remember I said the same direction, you do subtraction. So this, we are going to do subtraction here. You say this bigger one, you have the smaller one subtracting from the bigger one. So this one will give us, we have 79 degrees minus what? 46 degrees. Can you see it? Smaller one subtracting from what? The bigger one. Look at it here. They are the latitudes that we have. Latitude has to do with south and what? North. Longitude has to do with west and east. All right. So when you subtract this, you say 9 minus 6 will give us 3 and 7 minus 4 will give us this. So we have 33 degrees. All right. That is how it can be solved. I believe that you enjoyed the way I just solved it. Follow this page. Remember, this is Engineer Kenneth tutorial, and share this video so that it will get to the right students that need to acquire this knowledge. Bye.